Hello everyone, welcome to our channel. This is Pasha. Let us start our today's class. In our language, we often use different phrases like a bunch of keys, a bunch of keys, a bunch of keys. Next, to a class of students, a class of students, an army of soldiers, an army of soldiers. So here bunch, class and army, these all denote collections. In our mathematics, we use the word set to describe a well-defined collection of objects. Now in this class, we are going to discuss about a very important concept, set and representation of a set. What is a set? A well-defined collection of objects is called a set. A set is nothing but a well-defined collection of objects. Well-defined collection of objects is called a set. A well-defined collection of objects. What are objects actually? Everything in this in our universe, either living or non-living thing, is called an object. Next, well-defined collection. What is well-defined collection of objects? A collection of objects is said to be well-defined if it is possible to say beyond doubt, if it is possible to tell beyond doubt whether a given particular object belongs to the given collection or not. Beyond doubt, okay, whether a particular object belongs to the given collection or not. So here let us observe the collection of first prime numbers 2, 3, 5, 7, collection of prime numbers. So they have a common property, they all are prime numbers. So they have two factors, one and the number itself. So they have a common property and it is a well defined collection of objects. So hence it is called a set. Next let us observe another example, collection of vowels in English alphabet, A, E, I, O, U. These are vowels in English alphabet. They have a common property. They are vowels in English alphabet. Now it is a well-defined collection of objects. Hence it is a set. Now let us observe different examples. Let A be the set of first five prime numbers. First five prime numbers 2, 3, 5, 7. Let us take first four prime numbers. Let A be the first four prime numbers. Next here, let us see the relation between the set and elements of a set. Here 2 is an element in set A. Then how to denote it? So 2 belongs to A. 2 belongs to A. Next 3 belongs to A. Belongs to, it means 2 is an element in the set A, or else 2 is a member of set A. Next here also 3 is a member of set A and 3 is an element in set A. In the same way 5 belongs to A. Next 7 belongs to A. 8 does not belongs to A. Does not belongs to. It means 8 is not an element in set A. 8 is not a member in set A. Now let us take, let B be the set of vowels A, E, I, O, U. Set of vowels in English alphabet. Now here A is an element in set B. How to denote that? Small a belongs to capital B set. Small e belongs to capital B. I belongs to capital B. O belongs to capital B and U belongs to capital B. So nothing but A is an element in set B and E is an element in set B. I is an element in set B. Here if you observe, C does not belongs to the set B. Next small b does not belongs to capital B. Here do you notice anything? Do you observe anything? Here Usually the sets are usually denoted by the uppercase letters capital A, B, C, D's, and elements in a set are denoted by lowercase letters small a, b, c, d, a, b, c, d's. So this is the difference between elements and sets. Relation between elements and sets. The order of listing the elements can be changed. The order of listing the elements in a set. For example, let A be the set of numbers 4, 5, 6 and 7. These are the elements in a set A. The order of listing the elements. For example, the set can be written as 4, 5, 7, 6. The set remains the same. Or we can also written as 5, 4, 6, 7, or in many ways. So the set remains the same. The order can be changed. Next, if one or more element of a set is repeated, then the set remains the same. Here let B be the set of the elements A, B, C, B, B, A. Now some elements are repeated the same. This can be written as A, B, C. The set B is equal to A, B, C. The set remains the same. Each element in a set can be listed only once. If the number of elements in a set are very large collection, for example, the set of natural numbers between 50 to 100, the set of natural numbers in between 50 to 100. So we can write, let A be the set of natural numbers between 50 to 100. Here 51, 52, 53 and so on, 99 in between the numbers 50 and 100. So natural numbers between 50 to 100, 51, 52, 53, then followed by dots. We represent the set with by listing some elements, okay, 3 or 4 elements, then followed by dots. This is the way representing a set if the number of elements are very large. Till now we have discussed about what is a set. Then let us see what is not a set. Let us consider the collection of example 1. Let us consider the collection of interesting books. Collection of interesting books in a library. Observe this word interesting. The collection of interesting books. A book may be interesting to one but not the other. So the collection of interesting books in a library is not well defined collection of objects. Not well defined collection. Hence it is not a set. It is not a set. Let us observe the second example. Let us consider the collection of young players. The collection of young players of Delhi. Whether it is a football team or a cricket team, there is a team. The collection of young players of Delhi. There is no specified age to be young. Here we are not mentioning either 20 years or 25 years, whatever it may be. So there is no specified age to be young. So we can't write definitely who are the members of this collection. Hence it is not a set. Not a well defined collection. Next, example 3. Let us consider the collection of rich persons. Collection of rich persons in Hyderabad. So here there is no specified definition to be rich here. It is not a well defined collection. Hence it is not a set. It is also not a set. So by this you can understand very clearly what is a set and what is not a set. How to identify the elements of a set. Now let us see representation of a set. A set can be represented in three ways. Those are, first one, roster form or tabular form, and the second one, description method, and the third one, set builder form or rule form. Third one is set builder form or rule form. Let us see one by one. First one, roster form or tabular form. In this method, we just make a list of elements in a set within braces. We just make a list of members of a set within braces. For example, let A be the set of natural numbers less than 5. So A is equal to 1, 2, 3, 4. Let A be the set of natural numbers less than 4. And let B be the set of even numbers less than 15. Those are 2, 4, 6, 8, 10, 12, 14. Less than 15. These are the set of even numbers less than 15. So next, let C be the set of first 5 prime numbers. 2, 3, 5, 7, 11. So these are the first 5 prime numbers. This is the way we have to represent a set in roster form. Next one, description method. Under this method, we just give a description of members of the set within braces. In description method, let A be the set of natural numbers less than 9. Let A be the set of natural numbers less than 9. Here, natural numbers less than 9. So here we are giving a description of members of a set. Natural numbers less than 9. It means 1, 2, 3, 4, 5, 6, 7, 8 up to 8. So it gives us elements of a set. And let B is equal to set of all days in a week. All days in a week. It is also well defined collection. So all days in a week. In this way we have to give the description of the members in description method. Then next, third one is set builder form or rule form. Set builder form or rule form. Set builder form or rule form. In this method, we write the variable first. Then followed by a property which is satisfied by each element in the set and within the braces. For example, the set of natural numbers can be written as 1, 2, 3, 4 like this. Here, look at this. And next to set of rational numbers, Q is equal to P by Q, where P comma Q belongs to Z. Next, Q not equal to 0. Q is non-zero integer. So here we are mentioning first a variable, then followed by a property which is satisfied by each element in a set, then any condition, rule. Okay, next let another example. Let A be the set of natural numbers less than 9. A be the set of natural numbers less than 9. A is equal to X such that, it means in some cases we use forward slash and it is called as such that. X such that X is a natural number. X less than 9. So here we are mentioning a variable x, then followed by a property which is satisfied by each and every element. So this is the way we have to represent a set in set builder form, rule form. In the next class we will discuss more concepts by using this set